Hey everybody, welcome back to Factory Floor. I'm Jonathan Odom, and this is the final episode in our journey through the factory experience at AU. Now we're wrapping things up with one of the most powerful steps in the process, fitment and feedback. I'll share some insights we've gained over multiple projects and how they helped us level up the experience across the board. And in this episode, I'm going to show you the new factory product for AU 2025, so stick around till the end. Let's dive in. We'll just start with the first product here. And the cool thing about the factory experience is that we get feedback from one person to get two pieces of information. That one person is the person assembling the product and also the person that is using the product. So we're able to take that feedback and incorporate it into future iterations, or maybe even just scrap products altogether, so that we can keep serving our customer the way that they appreciate, right? So with this one, this was the first product, air quality sensor. This is me never having designed anything smaller than a museum exhibit. And so there are a lot of very strange choices here and mistakes that I certainly learned from. So one big piece of feedback we got from the very beginning was that this thing is kind of difficult to put together. So I pick it up and the screws fall out. I have this thing, okay, like what sequence am I in here? Okay, there's these parts, that's got to be plugged in. Now, if I'm looking at this and maybe I'm not that keen on following instructions, I'm the kind of person who likes to just kind of look at the parts and wing it. A lot of the people that go to AU fit that bill because they're designers and engineers, right? I'm guilty of that sometimes myself. So not everybody follows instructions. So what happened is I would look around at the assembly area and I'd see somebody start doing this. Well, that's got to go there. Okay, this goes on, but how does this fit? And so the sequence isn't that clear. So you're relying a lot more on instructions in this case. So we would tell people, okay, get the screws in there first. Oh yeah, that makes sense. All right, and then they fall out when you tip them over. You know, just not the best, not ideal. Put this in. That works either way, right? Yeah, that works either way. Okay, I'll put it in like that. Oh, maybe this goes here. What ends up happening is, because this design does not incorporate that concept of pokey yoke very well, where there's only one way to put it together, wasting time, getting frustrated, without knowing how to put this thing together, it's not intuitive at all. We improved that slightly with the next product, but we were still kind of locked in with some of the decisions we made in the beginning. One thing we did with these was add assembly jigs that helped keep the screws in place. I don't have any of those left, but they sort of captured this. So we added a new kind of assembly product to the build. We improved the instructions. We made those a little bit more, flashy and encouraged people more the next time. But the problem remained that this product does not incorporate pokey yoke, and that there's too many ways you can put it together wrong to make it a good experience. One more thing I want to mention about the air quality sensor is that I was there on the floor watching people assemble things, and there was a guy holding one of these, and he was screwing this in really hard, just had the thing down on the table and was putting all his weight into it to try to get it to screw in. It wasn't screwing in. And I said, whoa, hold on. And then I opened his up, and he had his battery slipped out of the way, and he was screwing into the battery as hard as he could. So I caught him just in time to prevent this thing from exploding. When you pinch a LiPo battery like this, they can explode actually pretty quickly. So really important piece of feedback there. Don't design this so that the battery can get in the way of screws easily. There should have been another feature here to keep this completely out of the way of any screw that was going in or out. So safety, especially if you're talking about any kind of product that's got a battery in it, that's crucial. Moving on to this product, the conference badge. This was actually pretty interesting because we were able to do a limited run internally of a prototype that was 3D printed of this product. So we used the Pi badge here. That is a prototyping board that you can buy from Adafruit, and we made our own little casing and parts that interface, and this is a little lanyard strap. And then we had these done for an internal event, and then we had a full feedback portal that people went to, and it answered a bunch of questions for us. Is the size okay? Is it intuitive to put together? Is it just the right amount of pieces? Is it frustrating? Is it interesting? And we were able to take that and incorporate that feedback into this product right here, into the production model. Yeah, so the feedback we got from the prototype badge was that the number of parts was just about right, which is what we want to hear. That it wasn't really frustrating to put together. And then something we learned from this was we had these buttons here. This was a big one I noticed on site. Where's that other button? Oh, here it is. Okay. Now these buttons, again, Poka-yoke is represented here, right? There's clearly a right and a left. They are not shaped the same. They're not symmetrical. That the idea there was that it would make it so that they would only fit in one way, like this, right? They catch that little boss right there. They're perfectly in place. All works. But maybe 10% of people did this. And because it's flexible, they push down on that, right? And tried to put it together that way, which doesn't actually work and pinches stuff when you put it together. So that was one thing about this that made it difficult to assemble. The other thing was popping this little bezel in here. So this 3D printed part has a lip on the inside that interfaces with this part. So you have to kind of tweak it a little bit to get it in there to make it actually fit. And that was kind of difficult for some people. It wasn't too bad, but it was not ideal. The feedback we got from this was that we should try something new next year. I think part of the reason for that is that this thing would only run in demo mode. I explained in the electronics episode about how the supply chains made it so that we couldn't get software that would actually make this thing run. So that was disappointing because the idea was that we'd be able to, expand the product and do new things. And people really liked the idea of that, but we needed to do a product that was going to be perfectly aligned with the Autodesk brand. Something that we could use with Autodesk software ideally, which is how we came up with the keypad, the shortcut keypad. Now this product, as I mentioned before, we had some hiccups with it in terms of assembly, right? So that dyeing process for these 3D printed parts made everything just a little bit too big, and we weren't actually able to test that until we got the full production run. So that made this part really difficult to do. So you can see right now I'm trying to pop these in here. That one I could usually get without a tool. These other ones over here needed a tool. We had one of the guys from Xometry brought some soap down from his hotel room. We were using that to kind of grease the parts on here to get everything to fit together. We ended up pre-assembling a lot of them, so it's like extra work for the people that actually shouldn't be doing production. And then, the hardest thing to get right was getting the screen ribbon connector in there, along with this part coming on at the right angle without pushing it off. So all of these PCBs actually needed to be pre-assembled with this part right here together, which was a real pain, and it took a lot of time for me and my team doing that on site. Just to prep people so that they wouldn't get frustrated with putting it all together. So that feedback was probably the most useful of any of the products we've done. And the feedback we got from this was the most useful and had the best results when we incorporated them into the new design. So going from that, where there are several different places that you could call bottlenecks, literally pinch points in the design where the parts are, where the tolerances are too tight to actually put the thing together in any reasonable way. Moved on to this to make it more aesthetically pleasing. It goes better with the Autodesk brand. It's sleeker. Doesn't have parts that are really unnecessary. and the assembly experience is much better. I mean, look at that. All you got to do is, yep, slide that in there. Okay, that's good. This just goes on top, nothing to it. Push this down, click it on, put some screws in, and you're done. Major improvement in terms of feedback from version 1 of this to version 2. All without having to change the PCB. We were still able to keep the same design for that locked in, just changing other parts, a new injection mold tool for this, and we were good to go. All right, and that brings us to the new factory product that's going to debut at AU 2025. We're calling this a designer's multi-tool. We might have a better name for that. Did we make a decision about that, Kaching? I don't remember. Well, it'll probably have a flashy name, but it's a designer's multi-tool. It does a bunch of different things. This is, this is a prototype PCB we haven't programmed yet. I literally just got this screen like an hour ago, but this is a really cool product. So it has several different functions that are going to be useful to just about anybody that's an Autodesk customer. So function number 1 is a protractor, right? So you pull this out, and that's immediately going to get you into protractor mode on the screen, right? You'll be able to set angles, push buttons to store them. And that works with any one of the features. This also doubles as a carabiner, right? So when it's closed, you can hang that on a backpack or something. Over here, we've got 2 other features. So there's a distance sensor and a color sensor. The distance sensor works where, just like any infrared measuring device, you put it up against a surface, push the button, and it sends an infrared beam, bounces back, that tells you the distance to whatever it pointed at. Then the other thing it's got is a color sensor. So you'll be able to put this down on any surface, push the button, and it tells you the RGB or hex or HSV value of the color of the thing you just read. So you can put it on fabric, you can put it on a wall. Really useful for interior design and probably media and entertainment. And then it also has a level. So you'll be able to use this as a 2-dimensional level on a surface. So like a tripod or something like that would work. And then it's also going to have a level that does horizontal and then also plumb. So it'll work in any of those dimensions. These are going to be injection molded parts. So the casing is injection molded. This button is going to be 3D printed, probably nylon. Here's the PCB, and it's got a little breakout PCB that has those sensors on it for those other features. Yeah, and the PCBs are being done by Sunstone Circuits, which is a local company in Oregon. We did a tour with them, so you should check out that episode. They were actually making this breakout PCB right here in the episode. We got to see them manufacturing this tiny little thing right here. So this cap right here is probably going to be either CNC machined or 3D printed. We're not sure yet. This thing holds a magnet, and the magnet is spaced just so against a sensor on the back of this board so that when it rotates, it reads the angle, and that's how the protractor works. And then the arm is going to be CNC machined aluminum, and that is snap fit onto the bottom casing right here. So I'm gently trying to release these snap fits. This nylon material from the Fused One is very durable, but we're pushing the limits of the how the size this machine can deal with. The reason this product is so cool is that we worked with the Rochester Institute of Technology to develop it. So we've been working with them for almost 3 years now on this product. We started with a collaboration where they had all of their industrial design students go into groups at this event they have called T-, and they came up with product concepts for us. They were all good. I mean, I was really impressed with these students. We picked the top 3, and then this is the one we chose to actually develop and manufacture for AU 2025. So the students that worked on it are going to be there, as well as the professor, Juan Aguera, also Alex Lobos, who is a really well-known Fusion user and also the director of their industrial design program. But yeah, this is just off the machine. So really happy with how this is coming out. I think this is going to look amazing. All right, so that's it for this episode and for this series. Thanks for sticking with us through this. This is a project that's really important to me, and I hope you got as much out of it as I did. Don't forget to like, subscribe, and hit the notification bell so you never miss any future Shop Talk content and updates from the world of design and manufacturing.